Hello, grade 9. How are you? We are continuing with our section. Today I want us to look at algebraic equation. In other words, solve for x. We are trying to solve for x or solve for y, etc. So we have this question. It says solve for x. 2x minus 1 is equals to 3x plus 4. They want us to solve for x. It's so easy. Remember, we have learned how to expand, how to remove the brackets. So we'll apply that knowledge here. Alright. So here we have 2 times x, which gives us 2x. 2 times minus 1, which is going to give us what? 2, which is equals to 2x plus 4. Alright, so here the next thing that we are going to do, we need to transpose. So we are going to transpose this 3x to the left hand side. That is, you find the additive inverse. But the trick is, if it is plus, you move it to the other side of the equation. That is, if you transpose it, it's going to be minus. If it is minus, if you transpose it, it's going to be plus. So here 3x is what? Is plus. It's plus 3x. So if I transpose it, what am I going to get? I'm going to get 2x. If I bring the 3, I'm going to get minus 3x. Are we together? Okay, this minus 2 is still there. Let me write the minus 2. This one, I've written the minus 2. Is equals to, I've already transposed this 3x, so it's going to remain 4. Are we together? Then 2x minus 3x, we have learned like terms. So this like term is already grouped, so we are going to add and subtract. So this one is going to be 2 minus 3. What would I give you? Minus 1. Okay, so we are going to have minus 1x is equal to 4. Now if I transpose this minus 2, if I transpose it to the other side, it's going to be what? Plus 2. Okay. Now this minus 1x, I'm going to write it again. Is equals to 4 plus 2 is what? 8. 4 plus 2 is what? 6. Okay. Now, what am I supposed to do? I'm going to divide both sides by negative 1. So, see that I've divided this side by negative 1. Anything you do to the left, you have to do to the right. So I have to divide the right hand side also by negative 1. And so negative 1 divided by negative 1 is going to give us x. Then 6 divided by negative 1 is going to give us what? Negative 6. If you are not sure, you press on the calculator to get the correct answer. Alright? So, what am I supposed to press? Negative 1 divided by negative 1. What we want is the correct answer. So, it's going to give us what? 1. So, here is what? 1. Are we together? Good. Now, anytime you have 1x. Another way of writing it is x. So it's going to be x is equals to minus 6. So remember this, anytime you have 1x, 1y, 1w, the nicest way of writing it is what? If it is 1x, you say x. If it is 1y, you say y. Alright, so this one is going to be what? X is equals to negative 6. X is equals to negative 6. Okay, the next thing we are going to do, we are going to expand. This one also, it says solve for x. This one, 3x minus 2 is equals to 5x plus 3. So to solve for x, for this, we need to expand, which we know. So 3 times x, 3x, 3 times minus 2 is minus 6, is equals to 5x plus 3. Then you continue 3x, 5x. If I transpose this 5x to this side, is going to be minus 5x. Then this is the 3. If I transpose this plus 6, is good. Minus 6 is going to be what? Plus 6. Is that okay? Okay. Now, so now I have 3x minus 5x, and 3x minus 5x, what would that give you? Minus 2x. If you are not sure, press get the correct thing. Alright, so 3 minus 5 minus 2x is equals to 3 plus 6 is what? 9. If you know it mentally, is good. Alright, okay. The next thing that we are going to do is we need to transpose this minus 2. It's multiplying x. So what do? You divide. So you divide here by negative 2, this side also by negative 2. Is that okay? Then the next thing that we are going to do is, if I divide here by negative 2, I'm going to have negative 9 over 2. This negative, you can either write it in the middle or at the top. Then our next question, it says solve for x. We should solve this one for x. So what do? Expand. 8 times x, 8x. 8 times 3 minus 24. Then we have our 2x plus 1. Then we need to transpose this 2x. If I transpose it to this side, it's going to be minus 2x. Then I have my 1. Minus 24, if I transpose, is going to be plus 24. Then minus 8. 8 minus 2, or 8x minus 2x is going to give us 6x. Is equals to 1 plus 24, which is 25. So you divide both sides by 6. This side by 6 is going to give us 25 over 6. If I press this, it's going to give me a decimal. It's good you leave it as a whole number or as a fraction. Okay, so this is your classwork. You pause the video and do this one for me. Okay. Then let's look at this type also. This is a rational. So it says solve for x. This one is equal to 0. When it is equal to 0, that is where you use this method that I'm showing you now. Okay, what you need to do is cross multiply. Cross multiply. Just cross multiply. This 4 will multiply that one. This 5 will multiply that one. Is equals to what? 0. Now, then let's expand. 4 times 2 is what? 8x. 4 times 4 is what? 16. 5 times x is going to give you 5x. 5 times 2 is minus 10 is equals to 0. Okay, then we have this and this, they are like terms. So 8 plus 5 is going to give us 13x. Then 16 minus 10 is going to give us what? 6 is equals to 0. We are solving for x, which means we should make x stand alone. We say you make x the subject of the formula. So we want to make x stand alone. Transpose this plus 6 to this side is going to be minus 6. Alright. Then divide both sides, this side by 13, this side also by 13. Which is going to give us minus 6 over 13. Let's look at the next one. The next thing that we are going to do is we do the same thing, cross multiply. So 3 will multiply that one and 5 will also multiply this, equals to 0. Then expand, 3 will multiply this, 3 will also multiply that, 5 will multiply, and 5 will multiply 2 to give you 10. So 3 will multiply 3 to give you 9 x. 3 will multiply minus 4 to give you minus 12. 5 will multiply x to give you 5x. 5 will multiply 2 to give you 10 is equals to 0. Then 9 plus 5 will give you 14x. Minus 12 plus 10 will give you minus 2 is equal to 0. Transpose this minus 2 to this side is going to give you 2. Divide both sides by 14. This side by 14, this side by 14. Which is going to give us 1 over 7. How did we get 1 over 7? So I'm having my 2, 14. This gives us what? Okay, how did I get this? 1 over 7 is what? 2 over 14. So 2 over 14 gives us 1 over 7. Let's look at the next one. This is your classwork. I want you to do this classwork for me. It's 5 questions. Then let's look at this. If y is equals to this, calculate y when x is equals to minus 2. How are you going to calculate y? Okay, if this is equals to that, calculate y if x is equals to minus 2. If x is equals to minus 2, it means when you see x, you put minus 2 there. So this is my 2. 2x is the same as 2 times x. Is the same as 2 bracket x. Remember, bracket is what? Times. So this bracket is what? Times. What is the value of x? Minus 2. So this becomes minus 2. So this is x. 2 x is this one. Square is this one. Plus 4 x. Our x is this one. Remember, bracket means what? Times. Minus 3. Okay, so minus 3. If I press this on the calculator, let's see how I'm going to press. I'll have 2 minus 2 squared plus 4 minus 2 minus 3. So this gives us what? Minus 3. Okay. So this is your classwork. You do that one for me. pause the video and you do it. Then another thing you need to know here, I want us to look at something on types of rational numbers. So rational numbers, we know rational numbers are numbers that can be written in the form a over b. In the form a over b. Let's say this is a. In the form a over b. So rational numbers, they are numbers that can be written in the form a over b. Rational numbers are numbers that can be written in the form a over b. Alright, where a, let me put a into this, where a and b are integers, and b should not be equal to 0. B should not be equal to 0. I want equal, not equal to 0. Yeah, so b should not be equal to 0. Alright, so b should not be equal to 0. Now we are actually talking about types of rational numbers. This one is the definition of rational numbers. Okay, so rational numbers. So let's look at the definition here. So we say rational numbers are numbers that can be written in the form a over b, where a and b are integers, and b cannot be written, or b cannot be equal to 0. B is not equal to 0. Types of rational numbers. We have fraction, like this, a over b, a over b. These are fractions. Ne? Remember, we have two types of fraction. When we were in grade 8, we learned fractions. Grade 7, we learned fraction, improper fraction, proper fraction. We are not talking about that one here. Okay, we are talking about all the fractions, both improper and proper fractions. Ne? Okay, so if you have numbers like this, they are rational numbers. So I can include more. 50 over 100 is a rational number. Alright, so let's say 60 over 36 is a rational number. Okay, another type of rational number is integers. Integers, they are positive and negative whole numbers. Example, like -3, -4, -5, -20, 0, 1, 2, 3, 4, 5, 6, etc. Alright, they are rational numbers. Why are we saying they are rational numbers? Because we can write this one in the form a over b. How? I'm going to show you. Now you have this one. This -5, I can write it as -5 over 1. Is that okay? You can write it as what? -5/1. Then -4, I can write this one as -4/1. Are we together? Okay. -3, I can write this one as -3/1. Okay. Then -2, what can you write that one? I'm not going to write all of them, alright? So I have -2/1. So you in the house, you do another way of writing -1, 0, 1, and 2. You do it yourself, alright? Okay. Now, another type of rational number is repeating or recurring decimals. Repeating or recurring decimal. Now, if I have repeating decimal, it means it's continued, the same number appears, alright? So if I have 0,2 with a dot at the top, is the same as 0,22222. Are we together? And it continues like that. Is that okay? It continues like that. So this one is a repeating decimal. It's a rational number. Why? I can write it in the form A/B. I'm going to show you. Now, if I have 2 with a dot at the top, if I have 0,2 with a dot at the top, I can write it as 2/9.
And make me whole.
Are we together? Let's test it on the calculator. Let's press 2/9 on the calculator. 2/9. It gives us this, ne? 2/9. Press the SD. It gives us this. Press the SD again. We have this 0,2222, which is this one. Are we together? Good. So this can be written in the form A/B. So it's a rational number. Remember the definition of a rational number. It can be written in the form A/B. Okay. Now, the next thing I'm going to do is I'm going to split this. Okay. Okay, now let's look at 0,4 with a dot at the top. 0,4 with a dot at the top. What is it going to be? 0,4 with a dot at the top. This one, what is it going to be? It's going to be 4/9. Let's press 4/9 on the calculator and see what it's going to give us. 4/9. Now 4/9, it gives us what? 0,4444, which is the same as that, ne? What about this one? It's also going to give us 5 over 9. Are you getting the picture? So it is what? A rational number. Alright, let's check on the calculator and see whether 5 is going to give us 5 over 9. If I put 5 here, 5 over 9, 0,55555. So 5 over 9 is the same as what? 0,5555, like that. So it's a rational number. So if you have numbers like this, repeating recurring decimal like this, it's a rational number. Okay, another one, this type. If I have 0,25 with a dot on 2 and 5, what is it going to be? What is it going to be? This is 2, 5. The dots appear, or the dot is at the top on 2 and 5. Né? It's on both 2 and 5. So you must write them. So it's going to be 25 over. How many numbers are repeating? It's 2. 2 and 5. 2, 5, 2, 5, 2, 5. So 2 and 5 repeat. So it's going to be 2, 9. Remember, how many numbers were repeating? 5. Only one number was repeating, so it's over 9. One number is repeating, is over 9. So 2 numbers repeating is going to be 9, 9. 3 numbers is going to be 9, 9, 9. Is that okay? So let's check this on the calculator. Now if I check this on my calculator, I'm going to get 25 over 99. I've made it 999. 25 over 99. If I press this, I'm going to get what? 0,25252525, which is this. Are we together? Good. So let's do the next one. This one is also a rational number because I can write it in the form A over B. How? 0,401. When you put the dot on the first and the last, the middle one is automatically affected. So this one is going to be 0,401, 401, 401, and it continues. What is it going to be? To write it in that form, what is it going to be? 401. How many numbers are occurring, or how many numbers are repeating? 3. 401. These are the ones that are repeating. Alright, so 3 numbers are repeating, so it's going to be 999, 999. Alright, okay. Now this one is also a rational number because I can write it in the form A over B, but I'm not going to show this one here because of time. Another video I'll prepare something on that one. For this one, it's also what do you call a rational number. Let me just do one. You see this and this are only repeating, so this 0,2 is not repeating, so you separate it. 0,2 plus, it's left with 55555, né? So it's going to be 0, you have written these 2 already here, so it's going to be 0 there, but this 5 you have not written it, so it's going to be 55555, like that, né? How am I going to do that? 0,555, 0,5 with a dot at the top. Let me put it that way. So it's going to remain 0,5 with a dot at the top, like this. Where is my dot? Yeah. Okay, so here what we are going to do is we are going to write this one as in the form a over b. 0,2, remember we learned that 0,2 we can write it as a fraction like this. It's going to be 2 over 10. 2 over 10 plus 0,05. How are you going to write that one? Just write 0,5 is going to be 5. How many number is repeating? Only one. So 9. How many zeros do you have in front? 1 0 in front, 1 0 at the back. Then here, that's another way of also solving this one, but I'm only showing you this one. All right. Okay, so you can use your calculator. We have our 2, we have the 10 plus 5 over 9 0. What does it give you? 23 over 90. So we have 23 over 90. Good. Now let's check whether 23 over 90 is going to give us the value we have here. Let's check. Let's press 23 over 90. 23 over 90. Have you seen 0,25555 and it continues like that, like this, which is 0,25 with a dot at the top. All right. Okay. Now this one is something that I've added, né? So terminating decimal, these are terminating decimals as well. They are terminating decimals. Terminating decimal are also rational numbers because we can write it in the form a over b. I did one for you. Okay, let's look at this one. Find the value of x for which values of x if this is equal to this. It's a rational number. So first we must substitute -3 into the equation. When you see x, you put -3. So I have my 4, my 3, minus, instead of writing x, I'm going to write -3. You put it in bracket. If I press this on the calculator, let's see whether it will give us a rational number, because the question wants us to find and put a value of x into this. That will give us a rational number. So if I press this on my calculator, I'm going to get this. If I press it, it's not rational number. Remember, rational numbers, like, it should be repeating or it should stop. So it's not a rational number, it's irrational number. So this is irrational. Then if I substitute -1 into the equation, what am I going to get? I'm going to get -1, and it's a rational number. How do you press that? If I press this on the calculator, I'm going to get 4, 3, -1. And remember, there is minus in front of the value, so there's minus here. It gives us -1, and -1 is a rational number. I've already showed you that you can write it in the form a over b. This is going to be -1 over 1. Okay, so if x is equals to 3, if I press this on the calculator, it's going to give me error. If I put 3 here, met error, so just write not applicable. Okay, the value does not exist in the real number system. Then here also, if I substitute 4 there, so first if I have 4, then 3 minus 4, what would that give us? Error, so it's not applicable, né? Okay, the next one, find the value of x for which this one is a rational number. It's a rational number. Value of x for which this one is a rational number. So here you have your x is equals to -5. Substitute it's also going to give you a number which is not applicable. Press it and see. Then if I try with -1, you substitute into it. When I press this, I'm going to get 1, so it's a rational number. If I press this, let me put my negative outside, then have my 2, then 1 minus -1 gives me -1, so it's a rational number. The same applies to this. I'm not going to do that. If I press this, it's irrational number. Okay, this one not applicable. Okay, then this also, if I have a question like this, what am I going to do? It's going to be 1 times 1 over 4 times 2. Then we find the multiplicative inverse of this one. So division, we change it to times. If we change it to multiplication, this 4 will go up and the 1 will come down. So the 4 will go up to give you this, and the 1 will come down to give you that. Then 1 times 1 is 1, 4 times 2 is 8, times we have our 4 over 1. 1 times 4 is then 8 times 1. 1 times 4 will give you 4, 8 times 1 will give you 8. So 4 over 8 is going to give you half. So 4 over 8 gives you what? Half. Okay, so you do this one for me. Then look at this one. 3 sisters share 400 rand and divide it into 210, 100 and 90 rand. Rewrite it in a ratio and simplify. To do this one, I've written, so you remove the rand, remove all the rand, just write the numbers. Alright, I've written it in a ratio form, but I've not simplified it. I'm going to simplify it now. So you divide it by a number that can divide it. without a remainder. So I use 10. 10 can divide this, can also divide that, and can divide this without a remainder. So 10 divided by 10 divided by 10, 210 divided by 10 gives you 21, and 210 divided by 100, 210 divided by 100 gives you 10, then 90 divided by gives you 9. So we have this. So you are going to do this classwork for me. Okay, so we say bye bye.
And make me hurt.